In this video, we're going to look at all the factoring techniques that we can use to factor apart polynomial expressions. In our journey of factoring polynomials, the first method that we learned was called greatest common factor. And we use this because we can look for a greatest common factor given any number of terms in our polynomial. So the greatest common factor is our first method that we always look for. And then we graduated from that. We looked at two terms. There are special ways to factor two-term polynomials. One, we have the difference of squares, that if it happens to be in the form of a squared minus b squared, we know that it factors apart into a plus b times a minus b. If it is a sum or a difference of cubes, that a cubed plus b cubed would equal a plus b times a squared minus ab plus b squared, and then a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And then we have three terms, which you know this as the AC method, that if we look for two numbers that multiply to give us one number, that if we add those two numbers together, it gives us the middle term. So that would be the AC method. And then if we ever have an even number of terms, we'd like to use grouping. So even starting with 4, we'll group the first two terms up and the last two terms, see what they have in common, and so on, and that'll help us get to the factored form of that polynomial. So what makes this difficult is that a combination of these factoring methods can be used in any one particular problem. It's not just one factored form works for a polynomial. I could have one that uses grouping and then eventually use the AC method as well, or a difference of squares and so on. Okay, so let's try some examples. The first example that we're going to have here is this 6-term polynomial where we have x to the fourth plus 7x cubed plus 10x squared minus 4x squared minus 28x minus 40. Right away, I noticed that I have an even number of terms, and we just said right up above that if we have an even number of terms, grouping is going to be the best method to use for this. So I'm going to cut it right in half. I'm going to group the first three terms up and the last three terms and see what they have in common between each other. So I'm also using the greatest common factor in a way here. Well, looking at the x to the fourth plus 7x cubed plus 10x squared, the greatest common factor that we have from there is the x squared. So we take out those two exponents from our terms. What we're going to be left with inside the parenthesis in the first three terms is x squared plus 7x plus 10. Now what's nice about grouping is that if the parenthesis in the first terms is x squared plus 7x plus 10, then the second parenthesis that we have when we group has to be exactly the same. So I cheat in a way. And what I do is that I ask myself, there's some number that I have to put here that if you were to distribute it to the x squared that I have to get negative 4x squared back. And that number is going to be negative 4. And what we've learned with the grouping is that those terms that we factored out from our parentheses get grouped together as one parenthesis, so the x squared and the minus 4 go together, and the x squared plus 7x plus 10 go together. Now in the past, we usually say that we're done here, but we're really picky. We have to be very picky with these problems. We have to then go in and look at each parenthesis and say, well, does that parenthesis itself factor any further? We look at the yellow parenthesis, and what we'll notice here is that this turns out to be a difference of squares. Now, why do I know that this is the difference of squares? Well, first off, this is a square because we got the square term in it, but the number 4 is also a very special number because it is a perfect squared number. And then, what is the factored form of a difference of squares? We'll have it right here. I'm going to zoom in on it. Because it's in that form of a squared minus b squared, we need to figure out what those a and b numbers are, because the factored form of this would be a plus b times a minus b. Okay, so it's going to be the same exact terms and numbers in our parentheses, but a plus sign and a minus sign. So I look at this and say, well, what is the square root of x squared? Well, the square root of that is just x. And what's the square root of 4? What number times itself is 4? And that is 2. So then we know what our a and b values are. That we'll have that x plus 2, and then another copy of the x and the 2, but this time we just throw a minus sign in between them. So there we have the yellow parenthesis factored apart. Now we're going to look at the green parenthesis that we have. It's got three terms, so our method that we'd like to use here is the AC method. And you'll remember this by doing the arrow here, that we'll take 1 times 10. We're looking for two numbers that multiply to give you 10. But those two numbers, when you add them up, you should get 7. Those two numbers are going to be 5 and 2. And because these problems do require a little bit more work, it's nice to have some shortcuts available for us. The shortcut I'm going to show you here is that if the leading coefficient of the x squared is a 1, then we're just allowed to plug these numbers straight into our factors. And what you'll notice, again, this is a 1 here for the x squared, so we can take the 5 and the 2 and go straight to our factors and plug them in. So our factors then for the green parenthesis is x plus 5 times x plus 2. And what we have here then is our final answer. This is a complete factored form here. There are little things that we could simplify here, but we're just focused on pulling these polynomials apart to its most basic form. So x plus 2 times x minus 2 times x plus 5 times another x plus 2 would be the factored form of our given 6-term polynomial. Now, let's try another example. Let's do 2x to the 4th minus 3x cubed minus 5x squared plus 12x squared minus 18x minus 30. Again, we have 6 terms here. That's an even number. We'll group the first 3 terms up and the last 3 terms up and see what we have in common here. Well, the common factor between our first 3 terms is going to be another x squared. So that leaves us with 2x squared minus 3x minus 5 in our parentheses. Because we are doing grouping, the second parenthesis has to be the exact same of 2x squared minus 3x minus 5. So again, that raises the question. There's some number here that if you multiply it by 2x squared, you should get 12x squared back. Well, that's going to give us a positive 6 here. And then we take our x squared and our positive 6. Those go together as one factor. And the 2x squared minus 3x minus 5 is the second factor here. And again, be very picky. Do each of these parentheses factor again. And you might look at the yellow one and say, hey, I got a square term in there, but 6 is not a perfect square. But the other thing is, this is the plus sign. We don't have a sum of 2 squares. We have a sum of 2 cubes, but not a sum of 2 squareds. So really, this doesn't factor any further because we do not have a sum of squares. So the yellow, we're just going to leave it as it is. That's factored as far as it can go. But the green, however, we need to factor it a little bit further. Again, there's 3 terms, so let's use that AC method. Let's take the 2 times the negative 5 and try to figure out what 2 numbers multiply to give us negative 10. But if we add those 2 numbers up, we get that middle term of negative 3. Well, those 2 numbers are negative 5 and 2. And if you think back to the last example, we said that we could plug in these numbers. But here we can't. Our leading coefficient is a 2. So we're going to take those 2 numbers and we're going to replace the middle term with them in this way. Because negative 5x plus 2x is negative 3x, if we were to simplify them, we're going to unsimplify those like terms. Notice that we have 4 terms, which is an even number of terms, and we can go back and do grouping. What's common between the first 2 terms? That greatest common factor is x, which is going to leave you with 2x minus 5 in that parenthesis. Because we are doing grouping, the second parenthesis does have to match. So there's some number that if you were to multiply it by 2x, it stays at 2x. Well, the only number that we can multiply by to keep something itself is the number 1. So that tells us that the x plus 1 goes together as a factor, and the 2x minus 5 goes to as a factor. But we're not quite finished yet. These are the factors of this particular polynomial. But we also have that yellow factor that we had here. So we need to put all 3 of these together. The complete factored form of this example is x squared plus 6 times x plus 1 times 2x minus 5. All right, so we did some grouping with some AC method and some a difference of squares in there. What if we do a combination of cubes and squares? For the given example here, x to the 6th minus y to the 6th. The hint that I will give you here is that anytime you have a difference, let's rewrite it as a difference of squares before we revert to the difference of cubes. Okay, so why do I say that? Well, here's our difference of squares form. We have a squared minus b squared again. It factors in the 2 parentheses of a plus b times a minus b. Let's think of it this way. What if I rewrote the problem as this? Something squared minus something squared, kind of like that a squared minus b squared to the left. What we have to ask ourselves then is, what do I have to raise to the second power that will get us back to x to the sixth. Well, if you remember that if you have a power raised to a power, you multiply them. So what number times 2 is 6? That's the 3. So we say x to the third raised to the second power is x to the sixth. So the same thing over here. What do you have to raise to the second power to get back to y to the sixth? That's going to be y to the third. These right here are our a and our b. And if you look back over to our factored form, wherever you see those, the a and wherever you see the b, you get to put what they are equivalent to here. So an a gets replaced with the x to the third. A b gets replaced to the y to the third. So our factored form here, the a plus b, is really just x cubed plus y cubed. The a minus b is x cubed minus y cubed. And again, you might think, hey, we're done. But we're not. We got to be very picky here. What you should notice then is we have a plus sign here, so that's a sum. And we have cubes in our problem. So this is a sum of cubes. We have a difference in the second parenthesis and more cubes. That's a difference of cubes. And we have factored forms for both of those. Let me zoom back out here. And we have the sum of cubes and a difference of cubes. What are those factored forms? Well, here they are. If a sum of cubes is a plus b times a squared minus ab plus b squared, and then the difference of cubes is a minus b times a squared plus ab plus b squared. Let's figure out what those a's and b's are. So we'll go back to our problem. What would we have to raise to the third power to get x to the third power? Well, that's x. What do we have to raise to the third power to get y to the third power? That's a y. So wherever you see an a in our factored form, we're replacing with an x. Wherever you see a b, you're replacing with the letter y. So just for the pink parenthesis, because it's the sum of cubes, we have x plus y. And we need to fill in our second parenthesis. Now again, how do we find those? Well, here we square the first term. X raised to the second power is x to the second. Whatever goes in the middle, we're just going to multiply these two terms together. X times y is xy. In the third term, we square the last term. So y to the second power is y squared. So our pink parenthesis is completely factored. Now we'll jump over to the blue parenthesis. Because of the difference of cubes, then we'll have x minus y. And we fill in our parentheses afterwards. Whatever goes here is the square of the first term. So x squared. In the middle, we multiply our two terms together, which is xy. And then the third term, we square the third, or the final term, and then we get y squared. And there you have it. We took a polynomial that was only two terms, and we really strung it out into all of its factors. And our goal with this is eventually just to figure out what are the values of the x, or potentially the y, whatever our variable is in that polynomial. Okay, so I got one more problem to look at, and it's going to be, again, mixing the cubes and the squares. This time we have a to the sixth plus b to the sixth. Like I said previously, we always want to go with the difference of squares as opposed to the difference of cubes, but this is not a difference problem. This is a sum, and we do not have a factored form for a sum of squares. So we could try it, but it's not going to factor. So now we have to revert back to the cubes. So instead, let's do the sum of cubes. And a reminder, what's the sum of cubes factored form? Once again, a cubed plus b cubed. That's a plus b times a squared minus ab plus b squared. So let's fill in those parentheses. Let's rewrite it like this. What to the third power plus something else to the third power? Well, let's see. What to the third power is a to the sixth. We're doing a power to a power, so we have to multiply our exponents. What times 3 is 6? That's a 2, so I need a squared to get back to a to the sixth. What raised to the third power is b to the sixth? That's going to be b to the second power. So now wherever you see the letter a in the factored form, we get to put a squared. Wherever you see the letter b in the sum of cubes factored form, we get to put a b squared. So let's fill that in. So the a is going to be a squared. The b is going to be b squared. Fill in our second parenthesis. Whatever goes here is the square of this term. So you're thinking a squared squared, a power to a power. Let's multiply the exponents. 2 times 2 is 4. In the middle, we multiply our terms together. A squared times b squared. Since our variables are different letters, we cannot add the exponents. So it's just going to be a squared times b squared. And then finally, whatever goes here will be the square of this term. B squared squared, multiply the exponents, which gives you b to the 4th. So this one didn't take near as long to factor out. And there you have it. That's how you can